Hello and welcome to the Diascopic image analysis platform demonstration. This is a technology that we've been working on for about 4 years now, and the system is comprised of a piece of hardware that you see over there on the left and a piece of software that resides on a Windows-based laptop machine over on the right. Let's talk a little more about the hardware. This is the Ion. It is our microscope, if you will. It is the device that houses our optical train, our optomechanical components, a circuit board that facilitates communication between the device and the laptop machine. And it also houses the battery pack. This device is portable. We want it to be taken out into the field as well as being used in the clinical setting. The battery enables the device to run about 6 hours untethered to wall power, and it takes about 2 hours to recharge. You can recharge the battery while you're using the device. It's USB enabled. You can see the USB cable in the background there. The piece of software, as I said, resides on a Windows-based laptop machine, and we have targeted Mycobacterium tuberculosis as our first pathogen. So we've developed an image analysis algorithm that will auto-analyze the images that the device captures. I'm going to load a slide onto the device. I want you to see how simple that is. So I've got a MTB slide that's stained with the Zeal-Nielsen technique that we obtained from Pathcare Cape Town. I've loaded the slide onto the device, and now I will open the application. And you see there the methylene blue counter stain that's associated with the ZN technique. I'm going to open a utility that we call the Slide Navigator. It opened here onto the right of the screen. It contains the joystick, a digital joystick, a provision to coarse focus the specimen, to fine focus the specimen, or to autofocus the specimen. It also tells us where the X and Y coordinates are for the stage relative to a home location. So I'm going to autofocus this image. You can hear the device running in the background as it autofocuses. And then I want to show you fully automated analysis, which is our single slide automated technique. So I will open a utility here. I want to zoom in as well so that you can see what we're looking at. And you see here a light blue rectangle that is broken up into this array structure. Each of these white blocks in this array represents a field of view. And again, this is a field of view. So what that allows us to do, this sectioning of the slide into this array, allows us to set up a search pattern that we can now control the device and identify a pattern that we want to search the slide with. I've set one up here that works well for us. This is an 18 field 3x6 array. I've located it here on the slide because I believe the specimen is going to be on most slides in this area. For your reference, this area over here to the right represents the frosted section of the slide. 18 fields represents about 150 fields at 1000x. So I'm going to go ahead and start this execution. I'm going to zoom back out so that you can see what's going on. And you'll see in the background of the laptop machine that the image is changing, and if you look carefully you can see that the stage is moving as well on the Ion itself. You see now that the gray blocks are being colored yellow or red. In this case, this is a positive slide, so we expect to see some yellow and red blocks, maybe a green or two. The legend down here to the left identifies what's going on with the blocks, and the summary information here to the right tells us what's going on with our slide. In this case, so far, 8 images are positive, 3 are marked suspect, 2 so far are negative, and the X and Y coordinates of where the stage is are identified here. So all 18 fields have now been analyzed. The device is returning to the home location. You can see that on the left. And I want to point out that these 18 images are captured and stored in a directory that was created when we started the analysis. So I will offload the slide here, and if I want, I'd load another slide. When I wanted you to see how simple it was to operate the device itself. And if we zoom back in, you can see a summary of this fully automated analysis. So again, you have the array here of our search pattern, red, yellow, green. You have the summary here. You can see that it's back at the home location 0, 0. And again, all those images are housed in a directory that was created when we started the analysis. So I hope you can see that we've got a platform technology here that we think is very simple and will facilitate lab operations in labs that are looking at slides for the diagnosis of TB or other pathogens, malaria, parasites like hookworm, roundworm, fecal slides. We strongly believe that if you can see it with your eyeball, you can write an algorithm to detect it in an image on a computer. So I thank you for your time. If you want more information, you can take a look at our website, www.diascopic.com. Thanks for your time.